Hey there, grab a seat. Welcome to today's explainer. Since you're stepping into the world of building AI agents, I really want to save you from a massive trap I fell into early on. So consider this a bit of a mentoring session to help you solve one of the single biggest headaches in AI right now: scaling LLM tool integrations. If you've been working with language models recently, you know we're in the middle of a huge transition phase. Today, we're going to dig deep into a paradigm shift that will literally rescue your codebases from endless maintenance. All right, let's dive in.
If you are sick and tired of writing custom API wrappers for every single new tool, man, I completely understand your frustration. When we all started building multimodal agents with frameworks like LangChain or LangGraph, the process was just incredibly tedious. You want your LLM to search Wikipedia? Bam, you write a custom wrapper. You want it to query an archive research database? Yep, another custom integration. Connect to DuckDuckGo or a vector database? More custom code. You end up juggling dozens of API keys, handling individual rate limits, and parsing completely unique JSON structures for every single service. It's an absolute integration nightmare that just does not scale for a small team, let alone a massive enterprise app.
Which brings us perfectly to what I call the integration nightmare. Think about traditional REST API workflows for a second. Whenever your AI assistant needs an external tool, you've got to write that custom code. But here's the real problem. What happens when your agent needs 100 different tools? You have to write and manage all of that code. And worse, if a tool provider updates their backend, maybe tweaks their authentication or changes their API parameters, boom, your integration breaks in production and you're scrambling to rewrite everything. Now compare that to the new standardized approach: MCP connections. MCP provides a universal medium. It completely shifts the burden of managing updates away from you, the developer, and drops it squarely on the service providers. If an API changes, the provider updates the MCP implementation, and your agent just keeps running smoothly without a single code change on your end.
So, it's time to officially meet your USB-C for AI.
Enter the Model Context Protocol, or MCP for short. This is an open-source protocol introduced by Anthropic, and its entire purpose is to standardize exactly how applications provide context to large language models. Instead of your LLM communicating with a dozen different external tools in a dozen completely different ways, MCP acts as a single common language. All the tool providers just need to adhere to this one standard protocol, and suddenly your AI assistant can communicate with all of them seamlessly. It completely abstracts away the messy network and integration layers, so you can actually focus on building the intelligence of your agent.
I literally think of MCP like a USB-C port for AI applications. Think about your laptop right now. Use that one standard port to connect a hard drive, a camera, your phone, a monitor, whatever. The port doesn't care what the device is, as long as it has a USB-C connection. You don't have to write a custom software driver just to plug in a new keyboard, right? Well, MCP works the exact same way for your LLM. It's the one standard port you need to connect to a database, a wiki, a code repository, or a search engine. You just plug it in, and the agent automatically knows how to talk to it.
Let's step up to the whiteboard and break down the 3 pillars of MCP.
First up is Component 1, the MCP host. The host is simply the environment where your application actually lives and runs. This could be an IDE like Cursor or VS Code, it could be the Claude desktop app, or even a custom backend you built yourself using FastAPI. The host is the foundation. Now, if you want to configure this in your local IDE right now, here's a quick checklist for you. First, grab the official MCP extension for VS Code or Cursor from the marketplace. Second, define your local server execution path inside your MCP settings JSON file. This basically tells the host exactly where your tools live. And third, completely restart your host application to initialize the connection.
Moving on to Component 2, the MCP client. You see, the MCP host doesn't just shout into the outside world directly. Instead, it spins up an internal MCP client. This client acts as your dedicated internal communicator. Its sole job is to handle the actual requests, maintain the active session, and manage the two-way communication on behalf of the host. It completely abstracts the transport layer, whether you're using standard input-output streams or server-sent events, so your main application logic never has to worry about the underlying network mechanics.
And finally, we reach Component 3, the MCP server. This is the absolute crucial piece of the puzzle. The MCP server is the component that's actually connected to the third-party services, data sources, and external tools. The client we just talked about reaches out and talks directly to this server using the standard protocol. Now, as a junior dev, your path to mastering MCP starts right here at the server level. For your first practice project, don't try to connect some massive cloud database. Just build a simple, local SQL-Lite MCP server. Once you master passing those local database schemas to the LLM, then you can move up to building simple REST wrappers and finally tackle complex stuff like cloud vector databases. So the MCP server is what connects to your code repos, external databases, and third-party APIs. But the really crucial point here is that in a mature ecosystem, these servers are managed entirely by the service providers themselves. That means if a database company completely overhauls their API backend, they update their own MCP server. You, sitting over in your host environment, do absolutely nothing. Your calling mechanism stays exactly the same. But because these servers sit directly between your tools and your client, you absolutely need a solid developer workflow for testing. Before you ever deploy an MCP server to production, use the open-source MCP CLI inspector. It lets you mock LLM requests locally to ensure your server tools are responding correctly and returning the right context before you integrate them into your main host application.
Okay, let's actually step through a request.
Imagine we're stepping through a code debugger together. Step 1, you type a query into your host, and the host immediately asks the MCP server, hey, what tools do you have available? Step 2, the host takes your query, bundles it with that list of available tools, and sends it all over to the LLM. Step 3, the LLM dynamically evaluates that list and says, to answer this, I need to use this specific database tool. Step 4, your MCP client hits the server to actually execute that specific tool. And step 5, the database returns the data, the context is fed back into the LLM, and the LLM generates your final answer. Now, fair warning, as you build this, you will definitely hit connection errors. The most common is a connection refused error right at step 4, which usually means your host JSON config just has a typo in the server execution path. The second most common is a timeout error, where the external tool just takes too long to execute. To troubleshoot, always check your MCP client logs first. They'll tell you exactly which step of this flow broke down, so you aren't just guessing in the dark.
Let's look at how MCP plays out in the real world to bring all this abstract architecture down to earth.
Picture this. You're sitting in your IDE and you type this super simple prompt directly into your AI assistant. What is the weather in California? Sounds basic, right? But getting an LLM to answer that in real time used to require a ridiculous amount of custom API fetching, parameter parsing, and error handling just to give the model the context it needed to answer you.
In the old standard REST setup, you'd be stuck writing JSON parsing logic directly inside your main agent loop just to handle the response from some weather API. You'd have to manage HTTP sessions and untangled nested data structures right inside your assistant's brain. But with MCP, your cursor host just naturally reads your custom Python weather server, which cleanly exposes two simple tools, Get Alerts and Get Forecast. When you ask for the weather, your IDE dynamically utilizes that Get Forecast tool to answer your prompt without a single line of custom API wrapper code. Your main AI assistant stays lean and smart, and all that messy integration work is entirely isolated over in the standard server component.
So, bringing it all together, MCP is basically the universal adapter that scales your AI assistants effortlessly. Adopting this standard protocol means you are finally saying goodbye to those maintenance-heavy, super fragile custom wrappers that break the second a provider updates their service. Instead, you're saying hello to infinite scalability, where adding 100 new tools is quite literally as easy as plugging in 100 USB-C cables.
So I've got a question for you. Look at your current LangChain or LangGraph projects. Which of those fragile custom wrappers are you going to replace with MCP first? The architecture is ready, it's totally open source, and it is built specifically to drastically clean up your code bases. Take my advice, start with that local SQLi server, really master the protocol, and scale up from there. Get out there and build something amazing. See you in the next session.